Welding is an essential process in many industries. It is how we join metal parts together. There are several types of welding. Each type uses different equipment and techniques. Some common types of welding include shielded metal arc welding, or SMAW, also known as stick welding, is a versatile and widely used method. Gas tungsten arc welding, or GTAW, also called TIG welding, is known for producing high-quality welds. It is often used for precision work. Gas metal arc welding, or GMAW, also known as MIG welding, is a versatile process that can be used on a variety of metals. Flux core arc welding, or FCAW, is what we will focus on in this guide. It is a user-friendly welding process. We will provide a step-by-step guide to flux core welding. You will learn the basics and be ready to start your welding journey. Flux core welding is a type of arc welding. It uses a consumable electrode wire. This wire is filled with a flux. The flux acts as a shield. It protects the weld from the atmosphere. When the electrode wire is heated, it creates an electric arc. This melts both the base metal and the electrode wire. The molten metal and flux combine. They form a molten pool. This pool cools and solidifies. This creates a strong weld joint. Flux core welding is a versatile process. It can be used on a variety of metals. This includes mild steel, stainless steel, and aluminum. It's a great option for beginners. This is because it is relatively easy to learn. Before you start welding, you need the right tools and gear. Here is a list of essential items. Essential tools. Welding machine. Choose a machine designed for flux core welding. It needs to handle the amperage and voltage requirements of the wire you'll be using. Welding helmet. This protects your eyes and face from intense light and sparks. Look for a helmet with an auto-darkening lens for better visibility. Welding gloves. Heavy-duty leather gloves protect your hands from burns and spatter. Welding jacket or apron. Protect your clothing and skin from sparks and heat. Leather or flame-resistant materials are ideal. Optional but recommended tools: angle grinder. Use this to prepare metal surfaces before welding. It's also helpful for cleaning up welds afterward. Clamps. These hold your workpieces securely in place during welding. Wire brush. This removes slag and debris from the weld area. Chipping hammer. Use this to remove slag after welding. Soapstone marker. This helps you mark your workpieces for accurate welding. Proper metal preparation is crucial for strong, lasting welds. Follow these steps to get started. Clean the metal. Use a wire brush or grinder to remove rust, paint, oil, or other contaminants from the surfaces to be welded. A clean surface ensures good electrical contact and prevents impurities from weakening the weld. Grind bevels, if necessary. For thicker metals, grind a bevel or chamfer along the edges to be joined. This creates a groove that allows for better penetration of the weld metal. Fit up the joint. Align the pieces of metal to be welded. Use clamps to hold them securely in place. A tight fit helps prevent gaps and ensures a strong weld. Section 5. Setting up your welding machine. Setting up your welding machine correctly is crucial for safety and weld quality. Follow these steps. First, choose the right wire. Select the appropriate diameter flux core wire for the type and thickness of metal you're welding. Consult your welding machine's manual or a welding chart for guidance. Next, set the polarity. Flux core welding typically uses electrode positive polarity, also known as DCP. This means the electrode cable is connected to the positive terminal and the work cable to the negative terminal. However, always double-check your welding machine's instructions to confirm the correct polarity. Then, adjust the wire feed speed and voltage. Start with the manufacturer's recommended settings for your chosen wire and material thickness. Fine-tune these settings based on your welding technique and the desired weld bead appearance. Lastly, ensure proper gas flow if applicable. Some flux core wires require shielding gas. If you're using gas-shielded flux core wire, connect the gas cylinder and adjust the flow rate as needed. Section 6. Mastering welding technique. Now that your machine is set up, let's focus on welding technique. First, hand positioning. Hold the welding gun at a comfortable angle, typically between 15 and 45 degrees, relative to the work surface. Maintain a steady hand to ensure a consistent weld bead. Next, movement and speed. Move the welding gun along the joint at a steady pace. The speed of your movement will determine the size and shape of the weld bead. Practice controlling your travel speed to achieve the desired weld profile. Then, bead types. Different welding techniques produce various bead shapes, each with specific applications. Common bead types include a stringer bead, which is a straight continuous bead created by moving the gun in a straight line. It's good for general-purpose welding. A weave bead created by moving the gun in a slight side-to-side motion. This provides wider coverage and can be used to fill larger gaps. Also, sound identification. As you weld, listen to the sound of the arc. A steady, crackling sound indicates a good arc and proper welding parameters. Inconsistencies in sound can indicate problems with the arc, wire feed, or other settings. Finally, multiple pass technique. For thicker metals, multiple welding passes may be necessary to achieve the desired weld strength and penetration. Each pass builds upon the previous one, fusing the metal layers together. Section 7. Post-weld cleanup and inspection. After welding, it's important to clean up the weld and inspect your work. First, let's talk about slag removal. Flux core welding produces slag, a glassy residue that forms on top of the weld bead. Use a chipping hammer or grinder to carefully remove the slag. Next, we move on to weld inspection. Visually inspect the weld for any defects such as cracks, porosity, which are holes, or undercut, which is a groove along the edges of the weld. If necessary, use non-destructive testing methods like dye penetrant or ultrasonic testing for more thorough inspections. Section 8. Safety first, protecting yourself while welding. Welding involves inherent risks. Prioritize safety by following these guidelines. First, wear proper safety gear. Always wear your welding helmet, gloves, jacket, and other protective clothing while welding. This shields you from intense light, heat, sparks, and potential burns. Second, work in a well-ventilated area. Welding fumes can be hazardous. Ensure adequate ventilation to prevent the buildup of fumes. Use exhaust fans, respirators, or work outdoors when possible. Third, fire prevention. Welding sparks can ignite flammable materials. Keep your work area clean and free of clutter. Have a fire extinguisher readily available and know how to use it. Finally, electrical safety. Never touch the electrode or work clamp while the machine is on. Ensure all electrical connections are secure and in good condition. Section 9. Benefits of flux core welding. Flux core welding offers several advantages, making it a popular choice for both beginners and professionals. First, versatility. Flux core welding is suitable for a wide range of metals and thicknesses. Second, portability. Flux core welding machines are often portable, allowing you to weld in various locations. Third, outdoor use. The flux core process is less susceptible to wind interference compared to gas-shielded welding, making it suitable for outdoor applications. Finally, cost-effective. Flux core welding can be more cost-effective than some other welding processes, as it doesn't require shielding gas except for gas-shielded flux core. Section 10. Conclusion. Start your welding journey today. Mastering flux core welding takes practice and patience. By understanding the fundamentals, gathering the right tools, and prioritizing safety, you can embark on a rewarding welding journey. Remember to start with simple projects and gradually increase the complexity as you gain experience. With dedication and the information presented in this guide, you'll be well on your way to becoming a proficient flux core welder.